Hey, APE students, if you can hear me, and Cindy's about to talk, so if you can hear her, put something in the chat, and if you can see our slides, perfect. Cindy, do you want to test your mic for a second?
Hi, I'm Cindy. I'm a new student. Oh. Okay. Can you guys hear me?
Can you hear me or Cindy? Hello, Matthew, Dakota, Tanya, welcome. Looks like Cindy is having some Wi-Fi issues real quick. Okay, so I think that I will just get started and see if Cindy can get back on. Can any of you guys see Cindy right now? Oh, and it looks like Cindy has left the building. So I can introduce for both of us. So, hi, I'm Harrison Burnside. You guys probably already know me from, a lot of other H streams. But, okay, so it looks like she is still here, so I'll just introduce myself and I'll let her introduce herself too. So, I'm Harrison Burnside. You probably already know me. I'm a sophomore from Dallas, Texas. I stream for Fiveable, and I've been streaming since, when was it? January, I guess, was my first stream. And my first stream is actually APE, so this is my first Fiveable class. I think I'll kind of pull up the different stream calendar and social media slides that we always have. So here's our weekly stream calendar as Cindy's trying to get back into the stream. So, watch the streams for other classes. And then, so for our social media pages, we would love for you to follow at Think Fiveable on and watch for these rotations. TikTok, Twitter, Instagram, and YouTube. I added in those cool spin effects on the images, and I hope that you actually see that. Tanya, I teach AP Human Geography for Fiveable, and next year I'm going to be adding some more AP subjects too. So watch out for me on those. I also teach AP Human Geography and AP Environmental Science for Fiveable, and I write for AP Stats this year. So yeah, coolio. So while I am having Cindy try to get back in here, I hope that her connectivity issues can resolve themselves. Welcome to the AP Environmental Science Q&A student-led study session. There are some questions already in the Ask a Question section, which I'll get to. Cindy wanted to take one of those, so I'll kind of leave that one for her. But yeah, so I will get started. I have a special slide for answering questions here that I may or may not have stolen from another H streamer, but don't tell. All right, so Samantha says, can we go over the different biogeochemical cycles and what we need to know? Is Samantha here in the chat, so I know that she's actually here to listen to my answer to her question? Yes, Samantha is here. Perfect. So I'm going to screen share a Fiveable resource. So biogeochemical cycles, they're kind of an iffy subject in APES, if you ask me, because you need to know 4 of them, but you don't really need to know them like perfectly. Like you don't need to know every step. It's not like that special. This isn't like AP Chem or Bio. Like you don't need to know every single step of it. You just need to have the general idea. So I would make this like Fiveable page bigger if I could, but I can't because Cindy is the head streamer today and she is having Wi-Fi issues. So I'm going to post the link to the page that I'm on right now. It's the Unit 1 Fiveable Study Guide page. So if you go there and you watch my stream and you read the study guides, I don't think you can score Olympics points in 2 tabs, but it was worth a shot. So here. So we have 8 study guides, and there are 4 different biogeochemical cycles that these guides cover. So I'm going to try to read each of them. Okay, so it's loading. It's a loading page. So hopefully you guys are pulling up the window while my computer is taking forever to load. I really hope you are. Okay, so it doesn't look like it's going to work. So I can just talk about it. So the carbon cycle. Oh, no, it is working. Woohoo! No, I do not want to make this tab the one that scores Olympics points because I'm streaming and that is unethical. All right, so the carbon cycle. So I really hope you can see this image. Again, I was hoping to make it bigger, but Cindy is having some Wi-Fi issues. Let me see if she's back in. So carbon cycle. So there are three main forms of carbon in Earth. So there's carbon dioxide, which is a gas. We have carbon, just like straight up carbon in the Earth's surface. And then we also have carbon in fossil fuels. So carbon is found in coal, it's found in oil and natural gas. We use it for a lot of our fossil fuels and use it for a lot of our energy. So the thing that you need to know about the carbon cycle is that plants take in carbon dioxide in photosynthesis, and humans and plants and all animals let carbon dioxide out of their bodies through cellular respiration. So with the cellular respiration, that's when we're putting CO2 back into the atmosphere, and plants are taking CO2 out of the atmosphere through photosynthesis. Humans are taking CO2 away from the Earth's surface when we extract fossil fuels, and then humans are putting CO2 back into the atmosphere when we are burning fossil fuels. So the problem with burning fossil fuels is we're putting the carbon back in a place where we didn't find it. So we found the carbon in the carbon under the Earth's surface in fossil fuels, but we're putting the carbon back into the atmosphere, which is a problem, and that's why we have the issues with rising global temperatures. So I'm going to go back to the study guides page, and we're going to talk about the next cycle, the nitrogen cycle. So after it loads, I'll start by talking about the steps of the nitrogen cycle. So the only people who can convert atmospheric nitrogen, which is N2, 78% of our atmosphere is nitrogen. The only people who can convert nitrogen are bacteria. Bacteria are the converters of nitrogen. So humans can't just take in pure nitrogen. Bacteria on the roots of plants must take it in. So you can see that there are nitrogen-fixing soil bacteria and then nitrogen-fixing bacteria that live in the roots of different plants. And then, so that's nitrogen fixation, the first step of the process. And then after that, you have nitrification. So nitrification is when nitrogen-fixing bacteria convert that into something that things can use. Ammonia, ammonium, all of those things. And specialized bacteria can then, in the next step of the process, convert the ammonium to NO2 and then the ammonia to NO3. So then after that, we have assimilation, which is when the nitrogen gets taken up in the plant's roots as proteins or as nucleotides. And then after that, you have denitrification, which is when nitrogen is released back into the atmosphere as a gas N2. And then our next cycle is going to be the phosphorus cycle. Now, there isn't really much you need to know about the phosphorus cycle. There is one thing you need to know for the APES exam about the phosphorus cycle. It does not have a gas phase. Phosphorus is the only major cycle that you have to learn in APES that does not have a gas phase. Carbon has CO2. Nitrogen has N2. Sulfur has SO2, sulfur dioxide. Hydrologic cycle, water, we have water vapor, a gas. But with phosphorus, there is no gas form of phosphorus. That's the really only thing you need to know about phosphorus. But with the water cycle is probably something that you learned in about, I can say that I learned it in about 3rd grade, I think. Yeah, I learned the water cycle in 3rd grade. So basically you learn that water comes down to the earth from the sky in rain. It gets pulled back up into the sky through evaporation. Maybe later in life you learned about condensation and how things, when they're sitting out in the sun on a hot day, the water comes directly. But there's really one more thing about the water cycle that we add in APES, and that's called evapotranspiration. So water is probably one of the most important biogeochemical cycles because it has evapotranspiration. So all water that has been evaporated or transpired is known as evapotranspiration. So plants are the ones who complete the whole evapotranspiration process because they take it in their leaves instead of pulling water up through their roots in the soil like they normally do. So you see a lot of trees that do evapotranspiration. And Tanya asked, hydrologic cycle is just another name for it. Yes, hydrologic, hydro meaning water, Logic meaning, well, I don't know, I could just use logic to figure out that hydrologic means water cycle. So Samantha, I hope that I defined biogeochemical cycles well enough for you. So I'm going to put like a little check mark emoji there since I can't clear these out because Cindy is not here. So, oh yes, so Tanya actually brought up a good point. So hydrologic is the name for the water cycle, but hydraulic is a kind of fracking. So you guys haven't really talked about fracking in APES because that's really more of a Unit 6 and 9 like crossover subject. That's not really like just, it's not just a Unit 6 concept because fracking is more of like a debatable issue and it's all about global change and stuff. So you guys haven't really talked about fracking a lot, so you don't have to worry about the word hydraulic fracking coming up on your AP exam. It's also known as hydraulic fracturing because they're fracturing into the Earth's surface, and that's where it got the name fracking. It's like the shorthand for it. But now I want to talk about another question that I saw. So don't worry about hydraulic fracturing or hydraulic fracking or just fracking on your AP exam because you probably won't see it. If you see hydrologic, they're going to be talking about the water cycle. So now somebody else in the Ask a Question section, I think that was it Matthew? No, it was Dakota. Dakota, if you're here, I'm going to go over the Coriolis effect. So Dakota, the Coriolis effect is about global wind patterns. And I don't know, my screen should be sharing, but it does not look like it is. Looks like my computer's having issues today, and I don't have Cindy here on the Fiveable account, so I'm sorry about the technical difficulties in the stream, guys. I don't know what happened to Cindy. This was supposed to be her stream to head, so after I talk about the Coriolis effect for a little bit, I'm going to go check on Sydney, and then I can get back to you on the Haber process, Matthew, since you asked about that one. So I'm taking most of these answers that I'm getting about the different cycles and all the questions that you ask. I'm going to try to get these from Fiveable study guides. So let me post the link to the study guide that I'm reading. Cody Williams, a former APE streamer, wrote this study guide, and this part is from Unit 4, which is about the atmosphere and soil. And so this part of the study guide is about global wind patterns. This one's about the atmosphere. So if you want to click on it in the chat, Coriolis effect is at the bottom of the page. So basically, Coriolis effect is the reason why winds don't go in a straight line. So the Earth is curved, right? Unless you believe and you're like a flat earther or something, which if you are, you can leave this ape stream. There are 25 people here. I could appreciate only 24 if I had a flat earther in here. But the Earth is round, right? So the Coriolis effect is why things don't move in a straight line around the Earth. Because the Earth is curved, things move in a special way that's opposite of how we think of them. Sometimes the Coriolis effect is a confusing topic, but I really like Cody's explanation here. So he said to draw a straight line on a spinning cup. The line will be curved because the cup is spinning. So as the Earth is spinning, things are moving in a circular pattern even if you don't realize it. They're not just going straight across. So when I throw this pin straight at you, straight at my computer, it actually curved down because A, gravity, but B, it didn't just go down because of gravity. It also curved a little bit because of the rotation of the Earth. Now, if I threw a much heavier object over a much longer time period and I went in slow-mo, I might be able to see the actual Coriolis effect in action. And you guys can just see that I have earned 20,000 points for being on the Fiveable stream page for hosting the stream with you guys. So the Coriolis effect is basically things just move in opposite patterns of the way they think they do because the Earth is round and not flat. So I hope that explained that for you, Dakota. So I'm going to get to Tanya's question and Matthew's question in a second, but I really want to go check on Cindy right now. So give me a second to text her, please. Sorry, guys. This is really unprofessional stream etiquette. I'm just trying to get Cindy back because this is her. While I'm doing this, I'll talk to you guys. So this is going to be Cindy's first live stream ever for Fiveable. So if you guys want to welcome her to Fiveable in the chat, that would be awesome. So when she comes back, she can see that. But Cindy is doing her first Q&A stream today because she and I are going to be streaming with Mr. Joshua Nielsen, the APES cram teacher, for the 5-hour cram session. So the night before the exam from 4 p.m. Eastern to 9 p.m. Eastern, we're going to be hosting a 5-hour, yes, you heard me right, 5-hour cram session to help you prepare for the exam. So you can either get into this 5-hour cram session by having a cram pass, or by, I think around tomorrow, we're releasing a platform where you can just pay $5 to get into just the 5-hour cram session. So I hope that you guys really do get excited about that, because Cindy, Mr. Joshua, and I have been planning this, what we're going to do during the stream, what activities we have, all sorts of other things, and other stuff. So I really hope you come. I've just texted Cindy, and I'm waiting for a response on her. We might actually be hosting another Apes Q&A tomorrow if Cindy does not get back to me and she's still having Wi-Fi issues. So, oh, Cindy's back. Welcome back, Cindy. Cindy. Oh my gosh, I'm having such trouble speaking today. You can't get your mic and camera working. Yeah, I see she's in the chat. Tanya, thanks. How can I troubleshoot this? I'm not logged in as Fiveable right now. I'm logged in on my personal account because I'm a secondary streamer. Sorry, guys. I'm going to talk through how I can help Tanya. Help Cindy fix this. Samantha, I'm logged in as myself right now. So you guys, if you're on the Fiveable stream page, like where you're going to get Olympics points and stuff, that's great. Stay here. What I think is about to happen is I'm about to stop the stream and cancel it. But stay on the page. Like, I promise I'm coming back. Like, I just have to do this to cancel the stream real quick. So stay on. I promise we'll be back in like 2 minutes. If we're not back in 2 minutes, have Samantha text me. Yeah, actually, Samantha, can you log in as the Fiveable account real quick? Thank you. That might make this a lot easier so I don't have to stop the stream. Okay. So while we're doing that, I will answer some more Apes questions. So Matthew asks about the Haber process. Now, I don't have a study guide for the Haber process, but I can help explain it to you. So the Haber process is what combines hydrogen and nitrogen and makes them into ammonium. So this ammonium can be used in synthetic fertilizers, which kind of makes you draw the flow chart that the Haber process, which makes ammonium and other nitrate compounds that you can put in synthetic fertilizer. Then when we have runoff, that synthetic fertilizer is going to get into lakes and streams, and then those lakes and streams are going to, have eutrophication zones. So the Haber process is really what allows synthetic fertilizers to be a thing. It creates the nutrients that we use in synthetic fertilizer. Cindy has just texted me for help, so I'm gonna help her real quick. Give me 10 seconds, y'all. I don't care if you count to 10 because I am already ready to come back to y'all. Okay, so technically this is ammonification, but it's ammonification on a synthetic level. The Haber process was created by a guy named Fritz Haber and also his partner Carl Bosch that allows hydrogen and nitrogen to be combined to make ammonium. So this is the process we use to create synthetic fertilizer. Does that make more sense, Tanya? It's kind of like taking the natural life science process of like ammonification in the nitrogen cycle and then making it into a synthetic fertilizer that we can use to increase our productivity and like our high yields in farming. All right, so I hope that helped. So it only makes a little bit of sense. Oh, it looks like we have Fiveable here. Is this? It's Cindy. Okay, Samantha, please do not log in as Fiveable. I hope you can hear me. Hello, Cindy, you're back. Yay!
Okay.
Okay, so while you were gone, Cindy, we kind of talked about the Haber process, the Haber and Bosch process. We talked about the Coriolis effect and biogeochemical cycles. So does anybody have any questions besides Tanya's in the Ask a Question section? Does anybody else have any Apes questions that Cindy can help answer?
I think I answered the Coriolis effect and the
yeah, you did help with that. Yeah. Anybody else have any questions? There are 27 people here. I hope that 24 of you are not just here for Olympics points. I hope that you guys are actually here to ask questions. Let's see. Okay, so if you guys don't have any questions, do you want to do a quick unit overview? Okay. So Matthew, I'll actually take this question, Cindy, because I know. So you can take Kay Perkins's question in the chat if you see that, but I'll take Matthew's. So what math should we expect on the AP exam? The only math you should expect on the AP exam this year is going to be basic addition, subtraction, and multiplication. Like basic. Because there is no propose an environmental solution doing calculations FRQ, you're not going to be expected to do anything like energy math. There will be no hard math on the APES exam. The hardest math that there might be maybe like looking at a graph and like subtracting numbers. That's the only math you're gonna have to do. It's like math based on analyzing graphs. So like there's no gonna be energy math, there's not gonna be any half-life stuff. It's really just gonna be all about, the concepts explanation. Okay, so it looks like you got that. They released that no calculator was needed for apes. So Cindy?
So Kay asked how the test will incorporate biomes. Not sure about this year's exam, but like last time I took the FRQ, there were some questions about biomes, like I think there was tundra and tropical rainforest. So basically, you know how you have to know like the distinctive points of each biome, and then like I guess like if the FRQ asks for the it's kind of like part logic, I'd say. Thing that's an FRQ. So I'd say that you should know the key points of each biome and answer, I think.
Yeah, so add on to what Cindy said, that was a pretty good explanation. But honestly, I think that you'll just need to know like where each biome is located for the exam, because the only way that I can incorporating it is like with a map maybe, and like you have to identify where the biome is and then like propose a solution to like stop global warming or something like that. That's really the only way that like I could see it, if they say like the tundra, the ice caps are melting, blah blah blah.
I think the tundra, it might ask about oil, but oil or ice caps melting.
It's 8-9.
Yeah.
Yeah. Tanya says maybe an experiment to show how biomes can transition from one to another. That's not really something you can design an investigation about, so I don't see that on the APES exam. Cindy, you might have a different opinion, but I don't see a question like what Tanya said.
Yeah, I don't think I can see that on there. But you can like go further into it, like research before the exam, so you might have some background outside knowledge.
Yeah, and like I said about the Fiveable study guides, we have a Fiveable study guide on that link I posted above with the Unit 1s about aquatic and terrestrial biomes. So if you're really interested in those, Kay, then you can go look at the 1.2 and 1.3 study guides from that link. Biomes are it's just a lot of fact memorization. There's no like trends. There's no like this leads to this, which leads to this. It's literally just like memorizing facts. So I don't love them either. You want to take the next one?
Which one's that? Oh,
do you want to take Scott?
Question?
Yeah.
What should we know about ecosystem services?
So actually, this is something that they've incorporated more into the 2020 exam when they like kind of rewrote the CED. So, I mean, I might have a little bit more insight on this since I've worked on the project with Fiveable looking at the CED before. So they've emphasized the ecosystem services more in Unit 2 than they have in past years, because if you guys didn't know this, Unit 2 did not used to exist in AP Environmental Science. There used to be a few of the key points in the Unit 1, but Unit 2 did not used to exist. Like, it's new for this year. So with the ecosystem services, what you need to know is that there are 4 of them: provisioning, regulating, cultural, and does somebody want to tell me the 4th one? Provisioning, cultural, regulating, and does somebody want to tell me the 4th one? Do you guys need a hint? Does anybody need a hint? So it starts with an S. Does anybody want to tell me what it is, or do I just need to spit it out? So what is the 4th ecosystem service? It's regulating, cultural, provisioning, and then the next one starts with an S. No, it's not sustainability. It's supporting. Sky, you're right. So there's regulating, supporting, cultural, and yeah. So there is a reason why you probably haven't heard of this before, Samantha, because I think if I remember correctly, you're one of the people who's self-studying the APES exam, and a lot of online classes haven't really changed for the new like exam format, and these are emphasized more in this year's exam than they have been in previous years. Like I didn't know about these until like I learned about them myself.
Yeah, same. I haven't heard of these before.
Yeah. So cultural is mainly just like going to natural parks and experiencing like the beauty. Supporting it, the ecosystem service is going to support the other things in the ecosystem. Regulating, it's going to help keep the ecosystem in homeostasis. And then provisioning is going to make things. So like provisioning service for trees is going to be like trees give us lumber, which give us, they give us lumber, which we can make into timber. You can take the next question about the El Nino and La Nina wind patterns, Cindy, but I want to answer this real quick. So if you join a live stream late, you can get Olympics points. You just have to stay on the live stream for about 35 to 40 minutes. So if you just stay with us till the end, you should be fine. Because if you joined at 4:30, 4:25, then you just have to be on until 5 o'clock, and then you'll get all your Olympics points, I believe, Angelina.
Okay, where's that question?
Something about El Nino and La Nina wind patterns, I think.
Was it asking for the difference between them?
Yes. Can you please go over the El Nino and La Nina wind patterns and differences, please?
Okay, so El Nino and El Nina are part of ENSO, or like the El Nino Southern Oscillation. So it's basically like a bunch of wind patterns and variation. So it's like a climate pattern that comes every year, I guess. Forgot. So there are two phases of ENSO, and La Nina is referred to as the cold phase, and did I say La Nina? Okay,
Yeah,
La Nina, yeah, it's the cold phase, and El Nino is the warm phase. So they both have impacts on ocean processes and global weather and climate changes. So like depending on where you live, like if you live near the coast, or I don't know, but depending on where you live, like these like wind variations might impact your area. And so like at some part of the year it might get hotter, or like the wind might be drier, and then they'll say, oh, this is because of El Nino. And El Nino, which is the warm phase, that occurs more often than La Nina, which is the cold phase.
Yes, it occurs in the Pacific Ocean, Samantha. They usually occur, El Nino occurs off the coast of like Peru and Ecuador in South America, and so does La Nina. El Nino takes the conditions that are in Australia and basically moves them to Peru, and then takes the conditions that were in Peru and moves them to Australia. So those are the places where it happens. But great explanation, Sydney. So let me take the next one.
Yeah, California.
You also have it.
I see Tanya's comment about El Nino. Yeah, I live in California too. Like when it's like dry and hot, they're like, oh, it's El Nino.
Okay, so Tanya asked, can you think of any crossovers between Unit 8 and 9 and Units 1 through 7 which may show up on the AP exam? This is such a complicated question. Like, Cindy and I were on a Zoom call earlier planning out the 5-hour cram session, and I think I said this like 3 times. I'm so mad that we took Units 8 and 9 off the exam, because like literally Unit 9 is just like a review of the course and adding in like how can I fix these things, and then Unit 8 is just like kind of recapping some things you've learned in Unit 5 and Unit 7 and Unit 4 and how they're bad for the environment. Units 8 and 9 are literally my favorite, and I hate why they took them off the exam. So the crossovers that I could see, I mean, they could ask you about like eutrophication on your exam, which is technically a Unit 8 topic, but you also talk about it with the nitrogen and phosphorus cycles in Unit 1. So that's how College Board could squeeze eutrophication onto the exam. You could just talk about literally like global warming if the College Board decides to get really sneaky and try to say that that's like an atmospheric pattern or something from Unit 4. Like, I really hope that they don't include these things, and if they do, like, it's just annoying. Like, they took them off the exam, so they probably won't include them on the exam. But like, because you haven't learned them, there's nothing that you're going to see on there. They're going to be like, oh, I didn't learn units 8 and 9, but I can tell you that LP50 is a unit 8 topic. The College Board should not have put that on the exam. You guys won't even be able to recognize it anyways, probably. That'll probably just look like, oh, darn it, I forgot that. But don't worry about units 8 and 9. Like, don't study them. If they put it on the exam, like, we can riot or something. Like, I don't care. You guys can protest against College Board, and you guys can get fun for all your money. Like, they're not going to put units 8 and 9 on the exam. They've said they're not going to for the past, like, since March 20th. So you don't need to study anything from units 8 and 9. There's a reason why they took them off the exam, so you wouldn't have to study them. So don't study them. Samantha says if they're on the exam, I'm going to sue you for telling me not to study it. I don't see how you can have a legal basis for that because it's not anything like defamation. It's not like so I don't see what you could sue me for. But I've also said that you can like just protest from the College Board and get a refund on your exam money. So I guess you could sue the College Board. I don't know. You'd have to figure that out, Samantha.
Just make memes about their exam.
Yeah, just make memes about the exam to get back at them. Okay, so let's see. What other questions do we have? Do you see any questions, Cindy?
Did you already go over photochemical smog, thermal inversion?
Ooh, no, and I have slides about those. So, Cindy, can you make my slides big by focusing on them for me?
Yeah.
All right, so today I said that we could go over like a unit overview, and I think you guys just asked about photochemical smog and thermal inversion. So, I mean, I can just talk about all of Unit 7 if you want me to, but there are kind of like some intro things that I want if you need me to like talk about photochemical smog, because that's kind of like a culminating thing you learn in Unit 7. So there are two types of air pollutants, primary and secondary. Primary pollutants are going to be things that we put directly into the atmosphere, like SOx, NOx, carbon monoxide, carbon dioxide, particulate matter, volatile organic chemicals, and chlorofluorocarbons. That was a mouthful. Secondary pollutants are things that combine with primary pollutants. So when primary pollutants combine with things like sunlight and UV rays, or they combine with water in the atmosphere, or even when primary pollutants combine with each other, they form secondary pollutants. So these are going to be things like ozone, which forms from any compound with one oxygen and then the O2 that we already have in the atmosphere, which makes O3. We have two types of acid rain here, which is going to be sulfuric acid when SOx combines with H2O. And then we have nitric. I think that's, my chemistry is rusty. It's going to be nitrous acid, I think. I think it's nitrous acid. Then you're going to have PAMs. And then you're going to have hydrogen peroxide when O2 combines with H2O. And then you drop the O from some VOCs. So how does photochemical smog form? So I'm going to try to click to that. I already talked about acid rain a little bit. So photochemical smog, it's going to be also known as brown smog. Photochemical smog is going to form. It's a secondary pollutant, so it's going to form when you combine, what is it? I think it's nitrates combined with UV or
nitrogen oxides.
Yeah, NOx is combined with UV, and they can combine with a single oxygen or like an O2 double oxygen molecule, which is also ozone. So when you combine the ozone, the UV, and the NOx, then you get photochemical smog. It's kind of like a tertiary pollutant, if you ask me, because you're combining a primary pollutant and a secondary pollutant, and you're combining UV rays. So photochemical smog is going to be like your tertiary pollutant. It's also going to be referred to maybe as brown smog on the exam. And photochemical smog is going to greatly affect areas like Denver and Los Angeles. So Los Angeles is in a valley, so it kind of simulates mountains around it, which is why the photochemical smog can get trapped between the mountains in the valley of LA. Denver is going to be surrounded by the Rocky Mountains, so that's why you have lots of photochemical smog in Denver and in LA, because of all the mountains and all the cars. Because you get NOx, does anybody want to tell me what the main source of nitrogen oxides are from? NOx, what's the main source? Does anybody know? Where does NOx come from? Come on, guys, you should know this. It's an air pollution reduction method. It may or may not start with a C. Come on, guys. No, it's not factories. Tanya's right. It's cars. NOx comes from cars. And actually, to come into thermal inversion, this is a great segue. NOx comes from cars, and it comes from catalytic converters. So catalytic converters take the awful pollutants out of car exhaust. So catalytic converters will take carbon monoxide and nitrogen monoxide out of the car's pollutant system, and it'll turn them into things like NOx, NO2, which is a lot less harmful, and then it'll take carbon monoxide and then turn it into carbon dioxide, which is a lot less harmful than carbon monoxide. So cars are what makes NOx. Coal combustion does not make NOx. Coal combustion is usually associated with SOx on the exam. And then, so to get rid of SOx, you usually use wet scrubbers and electrostatic precipitators and vacuum.
Connection.
What? Do you say something, Cindy? Okay. Oh, and I think we lost Cindy again, guys. Uh-oh. Okay, well, I'll keep going then. So then the last thing you asked about was going to be thermal inversion, if I could speak. So with thermal inversion, you have cool air, which is going to be close to the ground, which traps smog, photochemical smog, when the warm air rises. So this is going to be really common again in LA because photochemical smog is common in LA. And it's going to trap the pollutants near the ground, which is photochemical smog. So you can see here in this diagram below, which I really like, it kind of explains thermal inversion very well. The best way to explain thermal inversion is with pictures anyways. So in normal conditions, you have cold air at the top, warm air in the middle. The warm air is going to rise up to make the cold air warmer, and then the cold air is going to cool down because it's near the top. But then with a thermal inversion, you're going to kind of get a bubble effect around the city where the cold air is on the bottom, the warm air is in the middle, and the cold air is on top again. And the smog is going to get trapped in this bubble of warm air around the city when it's surrounded by cold air. So I hope that explains thermal inversion and photochemical smog for you, since you asked about that, Alondra. So, do you guys want to talk more about Unit 7 a little bit? We have some more slides to go over some Unit 7 concepts if you guys want that, unless you guys have other questions that we can answer. Let me scroll up. Raina asked, do we have to know the urban island effect? No, I don't think that you have to know that, because I don't know what that is. And I definitely like the urban geography stuff, so I don't think that that's something you really need to know for the exam. If that was one of the 2 FRQ topics that they picked, the urban island effect, which I didn't even know existed until you just said it, I'm pretty sure that they probably would not make that one of the 2 FRQs that they get to choose. So, does anybody have any other APES questions? I see Tanya doesn't have any. Alondra says thank you. Thank you for coming and asking your questions, getting your questions answered. So you guys just want to hear a little bit more about Unit 7? Oh, Sky had a question earlier. Let me scroll up and find it.
Sky.
Cindy, you have a
question.
Okay. Did Cindy drop out again? Oh, gosh darn it. Okay. See, this is why we have this Q&A stream, to be able to plan for our 5-hour cram session and make sure that all of our technology works, especially when it doesn't. So, Sky, I found your question, and it was all about what kind of graphs and maps can they use on the exam. And that's a great question. So let me keep going through this stuff. So, stimulus analysis. That's just kind of what I like to call this. Yes, I am very aware that I wrote you a multiple choice question. Yes, I did plan this. So, this map is something that you could definitely see on your exam. So I forgot who it was that asked about biomes earlier, and I really love that because you kind of just predicted what I was thinking. Like, who just read my mind? Who read my mind about biome? Was that Kay, you read my mind about biomes. I was thinking about it because I was like, what's a concept that I hate that I know they can give us with a stimulus on the exam? And And I thought about biomes, and I was like, that's not an easy way to put this into an FRQ. So I made an MCQ. And Cindy is back. She's coming back, I hope. So we have a map right here. Maps are going to be really easy.
What did you ask me earlier?
Oh, I'm sorry. I'm just kind of talking about stimuluses on the exam for Sky. Do you want to talk more about maps you could see on the exam? I kind of have an example map right there if you want to talk about that, Cindy.
Yeah, that one's about biomes, right? Other charts and graphs that might appear on the FRQ would be like population graphs. Wait, that should appear, right? Yeah. Yeah, mostly about biomes, population. Then they'll probably talk about like temperature, weather, and climate.
Yeah. So right here, I don't know if you can see this because I'm really small, but here's a picture of some age structure diagrams, also known as population pyramids. Something like this could definitely appear on your exam. You can also just have different charts. Like this FRQ doesn't ask me to do any math, but it still has a chart on it. You know, that's just something to think about. And then I don't know if this one, and then this FRQ is actually about urban sprawl and urban growth. I think that you answered this with another streamer. I think that the NIMSY people talked about this FRQ, the urban sprawl FRQ. This one has a graph and doesn't ask you to do any math. So they could definitely show you graphs and charts, but then not ask you to do math with them. So great question, Sky.
Someone, Rana asked what kind of experimental designs we can see on the FRQ.
I can help you with this one, Cindy, if you don't know. You know?
Yeah, please do.
Okay, so
not really. I think yeah.
Okay, so on the AP exam, you're going to have two FRQs. One of them is called Proposed an Environmental Solution, and that one's going to be your shorter FRQ, but then you have your longer first FRQ, which is going to be all about designing an experiment, designing an investigation. So that's experimental design. So what they're going to ask you to do in that FRQ is either analyze a lab experiment or write your own very basic lab experiment. So the kinds of things that we can see these about is going to be more like, let's think about this. So we could see these about things like integrated pest management. We could see these about reduction of air pollution. There was an FRQ about acid rain that was on the sample FRQs that I reviewed yesterday in an FRQ review stream. There can be a design experiment about soil sample, soil types that we talked about yesterday also. There could be one that asks you to design an experiment about any other Unit 5 concepts about agriculture. Really, you could see a design experiment about a lot of things, but mainly think about Unit 4, Unit 5, and Unit 7 as your design and experiment units. So, Rain, I hope that narrowed down what you need to study for that FRQ. I think that I'm going to take a break to take a sip of water because my mouth is getting kind of dry.
Stay hydrated. IPM. Oh. So Sky, I see that you've talked about your experimental design about IPM. So like pest management. Sorry, I'm gonna kind of answer Tanya's question. So experimental designs, like Harrison said earlier, they're like questions asking about like a solution for an environmental issue. So like let's say question could be about like tundra and like how people like drill oil there. So you can propose like what sort of like design sort of solution would you offer and propose for that issue? Yeah.
So
does that answer your question?
My FRQ review sessions, like yesterday, I'm pretty sure you were there when we talked about the acid rain, when we read that lab report about the calcium carbonate and the limestone. That's an experimental design FRQ. They're going to be called like design and investigation, design and experiment, or experimental design. Those are the names that we can call them. The experimental design FRQ is completely separate from the propose a solution FRQ. They are not the same thing. the experimental design FRQ is going to be about designing an experiment, hypotheses, control variables, but then your proposed environmental solution FRQ is going to be about fixing an environmental problem. If you want to go back and watch the NIMSY stream, they really definitely talk about this too. Oh, thanks for saying that in the chat too, Samantha. Oh, well, Tanya, you could go watch the NIMSY replay. I think I put that up there yesterday, so you can go watch the first 30 minutes. They definitely talked about designing an experiment then. Like, that was their main focus for the first half. Does anybody have any other questions? Raina, by second part, do you mean the proposed environmental solution FRQ or just like a different part of the question? I'm just confused about your question, Raina. Or Rana. I'm sorry, I don't know how to pronounce your name. So she says, the one other than experimental design. So the one other than experimental design is called propose an environmental solution. So with this FRQ, they're going to ask you about an environmental problem, like we could talk about things like using too many pesticides, human population growth. You can also talk about things like distribution of different animals. This one was really used a lot about global warming and climate change, but they won't do it this year because it's not on the exam. So this one is called proposed environmental solution, and you're basically just going to be proposing a solution to fix it. Now, one thing in the NIMSY stream that they really emphasized, which is a good tip, you're proposing a solution cannot be to ban the thing. AP readers will not give you points if you say your solution is to ban clear cutting. So say your proposed environmental solution FRQ said propose a solution to help reduce the clear cutting of old growth trees and forests. Your answer cannot be to ban clear cutting. That is not a correct answer. You have to pick something else. You have to pick a strategy like education or a strategy to give people economic incentives to reduce, or you could say talk about requiring selective cutting of only young growth trees. You kind of have to think about it that way. You can't just do anything willy-nilly. If you think about the required legislation, which there's also an APE study guide about, you can read about the required environmental legislation and how they've fixed some issues over the years and kind of take, inspiration from that. Does that help, Raina and Tanya, I think? So Samantha, yes, do selective cutting instead. And even though this isn't an FRQ stream, I feel like you could still get a gold star today. I don't know. I've given any gold stars earlier, so I don't know if Cindy knows this, but in my FRQ review stream yesterday, I started giving out gold stars, and Samantha got really jealous that she didn't get the first one. I think that it was Morgan who got like a platinum star, but Samantha didn't get a gold star, so she got kind of upset. Let's see. I think that some people tried to answer questions earlier. I don't know. I don't want to scroll too far up. So Samantha gets the first gold star of the day. Is there anything else that you guys want to talk about? Okay. While there aren't any questions, I want to do a quick, check to see what you learned. Let's go back to talking about air pollution. So we didn't really talk about acid rain a lot, but which of these equations is correct that shows acid rain? So equations are a big part of Unit 7, especially when you talk about primary and secondary pollutants. Does anybody want to tell me what letter is correct for this equation? What letter is correct for this question? Yes, I'm very aware this is a multiple choice question, but I also don't want a bunch of random answers in the chat that I have to go screen and do all of those different things. So this is just a lot simpler to check for your understanding of the topic. So I have 2 C's, 1 D. Looks like there's some competition in these answers. Let's go see. Aubrey says this gives me flashbacks of last year's FRQ. Oh, actually, I think I know which one you're talking about. Yep. Know exactly what you're talking about. All right. So it looks like we have 2 C's and a D. So Cindy, you want to help the person or people explain why they're wrong, or help explain why they're correct?
I see one explanation already, Rana. Yeah, because acid deposition comes from sulfuric acid, and so the answer is C. Yeah.
Yeah, so now everybody chooses C, but that's just because acid rain is a secondary pollutant, like we talked about on one of the previous slides that I can show you real quick, which was, we talked about acid rain, H2SO4, H2SO3 is going to be a secondary pollutant, acid rain. So this chemical equation right here shows you that the correct answer is going to be equation C. So equation D, what does equation D make? 2, 3, H2. That's just not a correct chemical equation. It's not balanced. So yeah, let's move on. So here's another question. So same answer choices, except D actually has correct answers this time. It has the correct product, so you can see how it's kind of in a different color. What's the answer to this question? So when I talked about catalytic converters reducing air pollution in cars, that's the question. What's the answer to my question? I can't talk today. And Cindy, you can take this one to explain too, after people put enough answers in the chat. Okay, Raina says B. Tanya, I changed it just to have the correct chemical formula because in the last question it says what is the correct chemical equation. So I didn't just flip the products, I actually changed and balanced it. Like I think the other one had like 2H2O or something, it just wasn't balanced. No. So is Raina the only one who has a suggestion? Well, I think that means that Raina is gonna get a gold star today because she's the only one with the correct answer. B is the correct answer. Do you want to explain why? Cindy?
Sure. So it's B because there's a catalytic converter that keeps NOx and carbon monoxide out of the air.
Yeah.
Yeah.
So it turns carbon monoxide into carbon dioxide and NOx into nitrogen gas, like we find in the atmosphere. 78% of our atmosphere is N2. So if N2 is bad for us, I think that we would all be pretty dead right now. Yeah,
there's
Raina,
more
you're
N2
explaining.
than O2.
Do you want to explain what catalytic converters are?
Nope. Sorry.
Wait, no, that's fine. That's fine. I can take it. So catalytic converters are inside of cars, and basically they take the really harmful pollutants that come from cars burning gasoline and make them into less harmful pollutants. So as you can see in chemical, I haven't even flipped it to show you the right answer. So the correct answer is B, like we just talked about, and it's flipping very slowly. But it takes the pollutant nitrous oxide, which is very harmful to the environment. NOx creates photochemical smog. You don't want that. And then it changes it into N2, a harmless gas in the environment that 70% of our atmosphere is made of. It also takes carbon monoxide, which is very, very dangerous and can cause carbon monoxide poison and suffocate you, and it turns it into CO2. It's a harmful pollutant because it's a greenhouse gas and it warms the earth, but CO2 is a lot less harmful than carbon monoxide. If we had as much carbon monoxide in the environment as we had CO2 in the environment, that would not be good for the future of our Earth and the future of your life. So I hope that explains.
Yeah. And I think the rest of the answer choices, they're actually like the ones that aren't correct, they're actually like reversed, right? Like the non-harmful chemicals turning into the harmful ones.
Oh, yeah, totally. So even if you didn't know what a catalytic converter was, you saw 3 of these answers that turned non-harmful chemicals into harmful chemicals. And then you see that this one turns harmful chemicals into non-harmful chemicals, the opposite. It does something good. So, Tanya, if you're still confused a little bit about catalytic converters, let me pull up my slide on the reduction of air pollution. So it says catalytic converters take off the pollutant side of car exhaust. You also have wet scrubbers and electrostatic precipitators, which reduce pollution from coal-burning power plants. So if you want to take a picture of this slide, Tanya, just so you can review what these things are. But yeah. So, Sky, there probably will not be an FRQ that makes you write out a chemical equation. Chemistry is not the main fundamental study of apes. And also, I don't see how you could use a chemical equation to design an investigation or to propose a solution. I don't really see how you can use chemical equations to do this, so just my opinion. Okay. Do you guys have any other questions?
Oh, for the FRQs, would there be questions about like diseases coming from air pollution?
So actually, Cindy, that's a really good question. So, in Unit 7, you do learn about some human health effects of pollutants. So, the main one that you need to know is asthma. Asthma is like the only thing that you need to know as an air pollutant. You kind of need to know lung cancer because that's just like that's non-specific. That's just something that everything causes. But then you also have emphysema, which is caused by a few certain pollutants. Asthma. So carbon monoxide causes carbon monoxide poisoning. That's the only special one. And how that works is your body breathes in carbon monoxide and it thinks, oh, this is about to be really scary. So your body breathes in carbon monoxide thinking that it's oxygen. So it goes into your lungs like oxygen does. And on and around your lungs, there are these little sacs called alveoli. Oh, I really hope I pronounced that right, and I'm sure I didn't. And basically, that's where the oxygen from your lungs enters your bloodstream so you can have oxygenated blood. That's how the blood carries the oxygen to the other parts of your body. And then the oxygenated blood goes through the heart and then gives some oxygen to the heart and then it carries oxygen to the rest of the body so it can function. So carbon monoxide enters your lungs. See, I just breathed in oxygen, but my body could easily think that it was carbon monoxide. And when the carbon monoxide enters your lungs, it'll enter your alveoli just like the oxygen does. So you get strangled, basically, from the inside out because the carbon monoxide enters your bloodstream, and then the carbon monoxide doesn't have anywhere to go. It just follows the oxygen path, and because the heart thinks it's getting oxygen, it'll get carbon monoxide, and the other parts of your body will also get carbon monoxide, and you can kind of like suffocate, basically, from carbon monoxide poisoning. Carbon dioxide poisoning is not really a disease by air pollutants that they test you on. So don't mention carbon dioxide poisoning because that's a really complicated topic, and that's not an air pollutant issue. That's kind of different. That's kind of just like CO2 poisoning is more like chemical warfare than it is air pollution. And then health effects of pollutants, you have particulate matter, which causes basically every lung disease. So particulate matter can cause a lot of things because it's a really wide range of things. Basically, particulate matter is any like solid particles of things that are in the air. So it's every air pollution that's not a gas. So any pieces of anything that gets into your lungs is bad because it can either like tear up your lungs, it can enter your bloodstream, the pieces of stuff can just like stay in your lungs and give you emphysema, you can have asthma, and then also things like SOx, VOCs, methane, and heavy metals cause bronchitis. Yeah, and PM also has different sizes, the 2.5 and the 10, which is another reason why it causes so many things. Tanya, you bring up asbestos. Asbestos is not an outdoor air pollutant, so they usually don't test the health effects of indoor air pollutants. The course and exam description only requires you to know the human health effects of outdoor air pollutants. Indoor air pollutants, you're only just required to know that they exist and that they're indoor air pollutants. So your indoor air pollutants are going to be asbestos, mold, and radon. You kind of just have to know that they exist. You're not required to know the human health effects of those for your test. Mercury is a heavy metal. So that's included in the things that cause bronchitis. Mercury is not as much of an indoor air pollutant as it is outdoor, and really mercury is more of a terrestrial pollutant in water streams and in food anyways. So I don't see
methane.
Oh, sorry, go.
Oh, I was gonna mention, like, in addition to mercury, there's also methane that, like, goes into water.
Yeah, true. So Sky asked me to go over the indoor air pollutants again. So at the bottom of this slide right there, we're kind of covering it up. But there are two types of air pollutants, indoor air pollutants. You have, in the developed countries, you have radon, asbestos, lead, and sick building syndrome, SBS. But in developing countries, you basically have every air pollutant just indoor. And the main reason that causes this is because they don't have electric and gas stovetops like we do. They basically have to have fires indoors, and they burn really bad things sometimes. I'm not even going to get into it because some of those might just gross you out. But, those are your air pollutants right there at the bottom of the slide. I hope you can see them like under us or whatever. But also, I'm going to link the slide to the resources of this stream once it's over so you can download the slides later too. Tanya, my teacher gave me a huge list, but heavy metals were listed as indoor along with radon and formaldehyde. Okay, heavy metals are more of a Unit 8 concept anyways. I personally don't think that they're indoor air pollutant. If your teacher thinks that they're your indoor air pollutants, then listen to your teacher. But I think that they're more of like terrestrial and aquatic pollutants, which is Unit 8, which you don't even need to know. And formaldehyde, yes, formaldehyde is an indoor air pollutant because you find formaldehyde in a lot of different furniture linings. Like old pieces of furniture are going to have formaldehyde, which gives you your colors. And then the old furniture sits for a really long time and goes through weathering and erosion basically inside of your own house because, your people are so messy. So then you kind of have, the formaldehyde gets out of the furniture, out of the lining, and then it ends up causing bad health effects for you.
You might also want to include like paint, like peeling off and chipping inside your house.
Yeah, lead is the reason why developing air pollutants. Lead is a heavy metal, but it's specific because it's lead paint, just like Cindy just said. Lead paint is only old paint, and it's now only sold as an outdoor paint. Like, very few stores still sell lead paint. It's really effective because it keeps the color for a really long time, and that's why we used to use lead in paint before we knew that it was bad for you. And they do still sell some very few lead paints, but like when you buy them, like your store has to like have you sign a thing that says like, I will only use this outdoors. Paint also has VOCs, right? Yes, some paints do have VOCs. You have to be very careful on like what you buy, what you use inside your house, what you use outdoor. Read the label on your paint. If it says outdoor, it only goes outside. If it says indoor, you can use it anywhere, but indoor paint is more expensive generally.
Yes,
504. So if you guys have any more questions, you can ask them, but I think we're going to wrap up soon, Cindy. You can take the last few questions, and Cindy's going to be the one that's going to end the stream too. So whenever we decide that we're done and we say thank you and all that good stuff, then we can,
All right. Thank you guys for coming. Thanks, Harrison.
Thank you, Cindy. I hope you guys see us again on the 5-hour cram stream. I am scrolling through the questions, and I do see a question at the 5-hour finale that I do want to answer real quick. For the 5-hour finale, we're reviewing the whole course. We're going to also create a tangible takeaway that I'm not going to reveal for you. We're going to give you something you can take away that you actually might be able to use on your exam. While I don't recommend using notes on your exam because it really just wastes time and you have a ton of points on your FRQ that you need to get, you can definitely use it to study like 10 minutes before your exam. So we're going to be giving you something in the 5-hour cram, so I really hope you buy a pass. There are some streams between now and the 5-hour cram. There's a cram session tonight with Mr. Joshua Nielsen, I believe. And I think that before the 5-hour cram, there was one more stream next week. There's another stream next week. So I hope to see you guys then. Thank you so much for coming. And Cindy, you can end the stream when you're ready.
Okay. Bye, guys.
Bye, guys.